Hey everyone, welcome to another video of hok'stutoring. I hope you're having a great day. Today we'll be doing question 18, the last question of the subtopic of inverse functions, so chapter 1F. This is there's gonna be a lot of algebra in this video, so make sure you have that banana sitting next to you for that energy boost. I'm fairly sure you're gonna need it. Alright, so let's get into the video. Question 18. Let's have a read. Let the function f with the domain of s, we don't know what that domain is, it's just some set, be given by the function fx equals to x plus 3 divided by 2x minus 1, where the subset, or s in this case, has the domain of R, so everything except half. Okay, well, why is that the case? Well, if you have a look, just quickly have a look, right? And you're trying to sub in half into the value of x. Just look at the denominator. If I sub in half, I get 2 times half, which is 1. 1 minus 1 is 0. And we know that we can't divide by 0 because the function will then be undefined. So that's why the domain is everything except half, or else the function will be undefined. So that's really nice of them. They actually gave you the domain. A question would have easily been, find the domain of this function, because, I mean, you can easily work that out, but they've just given it to you, so that's all good. Ignore that part. And then A says, show that FOF is defined, so composite function. And then B, find FOFX, so find the composite function, again, more composite. And then sketch a graph. Ooh, okay, so sketching a composite function. And then C is the inverse part, so it's just write down the inverse of F. Alright, so it's a composite and an inverse function question combined together. Before we get into answering it, I just want to go through a bit of revision on long division, because we're going to need it for this video, okay? So this function right here doesn't look really nice. You've got x on top of x, and we know when we have a variable on the numerator that has the same power as a variable on the denominator, you can long divide it, okay? So in this case, you've got x to the power 1, x to the power 1, they have the same power, so you can, simplify and make it look a bit nicer, okay? So just before we get into that, I'm going to do a quick revision on long divisions. We're going to need it for this video today. So very quick explanation. I have 5 divided by 2, and as we know, if you want to do the really long way, which is long division, then I write it like this: 2 and 5. And then how do I try to divide this? Well, you try to multiply 2 by the closest number to get to 5. In this case, we get 2 multiplied by 2 gets us 4, and then you have a remainder of 1. You can't divide that anymore, okay? So another way of writing 5 over 2 is 2 plus 1 over 2. Agree? I'm going to make it so that it's a bit more standard. So we call number 2 over here the divisor, so put as D, and we'll call this number 2 up top here as the quotient, Q, and then we call this remainder 1 as R. If you want to put a name to number 5, then that's just called the dividend, but we're not going to need it. What I'm going to show you is the formula for long division, I suppose, or how you write the end result of a long division. So you have 2, which is your quotient, plus your remainder, which is 1, R, divided by your divisor, which is 2, D over here, okay? So this is simply just another way of expressing a fraction, okay? That's it. We're going to need it. I'm going to show you here on this question. So yeah, so keep that in mind. We're going to need it for question 18. Right. Part A, show that FOF is defined. So that means I want to put this function fx into itself. So every time I see an x, I'm going to replace it with this entire function. Right, so moving on to question 18a. So the question is, show that FOF is defined. And if you know composite function and you want to know whether a composite function exists or is defined, you need to use the golden rule. The golden rule, as I've mentioned multiple times, is the range of the inside, okay, range of the inside function must be a subset of the domain of the outside function, okay? That's it. So the range of the inside must be a domain, or must be a subset of the domain of outside, so smaller or equals to. Right, well, FOF, that's the same function, right? Do we know the domain already of this function right here? Yes, we do. That is that, R, okay, except half, so everything except half. Normally I would draw a composite table, but we've literally got the same function. The domain and the range should be the same for both of them, okay? So now the question is, what is the range of the inside, right? Like we've not been given the range, we've been given the domain. So what the question is actually asking is find the range of f, okay? So find the range of this function right here. And this is where your long division this is where the long division that I did previously is going to come in handy, because if you don't have a calculator and you're trying to find the range of this, it's going to be a little bit complicated, right? So if you want to find the range, we need to split it into something that looks a bit more familiar, looks a little bit nicer, that you can easily find the range. So let's do that quickly. At the bottom, right? So what is our divisor? That is 2x minus 1. That's at the bottom here. And I am going to have my dividend as x plus 3. And I'm going to try find the answer, okay? So what is another way of expressing this? Right. What do I multiply? So with long division, I need to, try to simplify as much as I can. What do I multiply 2x by to get rid of this x? Well, the answer is half. If I multiply half over here, what I actually get, and I'm going to put a bracket so it's easy for you guys to see, is half times 2x is x, half times -1 is -half. And what you end up with, and this is good, x minus x is actually 0. So that's gone, completely gone. And the only thing you have left is 3 minus minus, which becomes a positive, of 3 plus a half then, which in this case is 7/2. Right, so what we have here is our divisor, our quotient, and our remainder, which is 7/2. So another way of expressing this function, which looks really ugly to start with, and it's going to be very hard to find the range unless you have a calculator, is we can recreate this function so it looks like this. So again, remember, for our first part, it is q plus remainder over divisor. So quotient is a half plus our remainder, which is 7/2, and then it is divided by the divisor, which is 2x minus 1 right here. And I suppose you can try to simplify this a little bit if you want to. That 2 can go to the bottom, so you get 2x minus 1. You can expand if you want, but all I want out of this is, if you look at this closely, what does it look like? There's now only one x in the entire equation. So now fx is this. There's one x on the denominator. What does this look like? Yes, it is. Yes, it might be popping in your mind, but it is this one right here, your hyperbola, okay? This is your hyperbola function. And with hyperbola function, the number on the outside is actually your horizontal asymptote, half, which means your graph, whatever it is, I'm just going to quickly draw it again, has a horizontal asymptote of a half, meaning the range is everything, okay? So wherever the graph is, the range is everything except half, right? So that means your range of f is actually r except half, okay? So there we go. We've just found our range of the function f, which at first glance looks really complicated because there's two x's, one numerator, one denominator. Haven't really seen this before, but now that you've done long division, converted to something that looks a bit more familiar, we now know the range. We can now find the range and therefore answer the question. Show that f of f is defined. Well, coming back into here, we know domain of f is r except half. Well, what is the range of f, the range of the inside? That's also r except half. And what do we see here? There are indeed so r of half is indeed the subset of r except half, because they're the same one. So in that case, we have now shown that the range of the inside is a subset of the domain of the outside, and therefore f of f is defined, or it exists. Okay, so guys, that is how you answer question 18a. Right, so that's that. Let's move on to 18b. So this is where the algebra is going to come in. All we want to do is find the composite function f of f, okay? So I'm going to put it down here, and let's rewrite fx, okay? Fx can be written as a half plus 7/2 2x minus 1. At the same time, it can also be written as, your original one where we had previously over here, as x plus 3 over 2x minus 1. So there's two ways of writing f, and we're going to use actually both of them to find f of f, okay, which is essentially f inside f. So that's what it means. We're going to replace, every time we see an x, we're going to replace it with this one right here, okay? Right, at this point, there's going to be a lot of algebra, guys, so to make it a bit more interesting, I might speed up the video a little bit, play on some music as well, so listen in. If you want, you can skip forward, fast forward to the final answer, but in this case, follow along and enjoy. Voila, we end up with x, and this is very interesting because when you put the function f inside f, you get x. And the question again, and this is, to refresh yourself, I'm going to bring it up here on screen. F part B, it says find f of f, which is we know as x, and we need to sketch a graph f of f. So we just need to sketch this graph, but keep in mind again that the domain, okay, so domain of f of f is r except half. Okay, so remember, the domain of the composite, it came from f, and therefore the domain of the whole composite is also the domain of f. So in this case, when I sketch the graph right here, linear line, I just sketch it normally. So f of x is equals to x, but with one exception, and a lot of students lose their mark here, and that's because they forget to put that open circle at x equals to half, obviously at y equals to half, okay? So guys, that is how you sketch this graph. Right, that was a very long algebra. Hope you enjoyed that part. We're going to move on to the last part, which is the inverse of the graph. And this one's less intense on the algebra. I'm going to bring the question here. The question again is essentially just to find, what is the inverse of the function f. We know the function f can be written as... Alright, now that we've got the function f with us, we can proceed to finding the inverse. And if you want to find the inverse, the rule is to swap x and y. So what's the best way? So you have to make a choice here. Which equation do I use? The first one or the second, the original one? The original one has two x's, and the one that we've got here only has one x. When you're doing inverse, the best way to do it is you want to just swap x and y where there's only one, so one each, okay? So you don't want to have two x's which then becomes two y's. It's a bit complicated. It's gonna get a bit messy. So what you want to do is swap this. So this is essentially your y, okay? Swap that y with an x and swap that x with a y. So what we get, I'm gonna do it here, is this becomes an x, and this one right here becomes a y. And all you need to do is now make y the subject. So we're going to start moving things over, so y is the subject, okay? 7 to 2y minus 1, x becomes x minus a half, and then we're going to bring the 2 over here and the 7 here. So what you get actually is 1 divided by 2y minus 1, and bear with me here, x minus half. I'm going to bring 2 up top and 7 to the bottom, okay? I'm just multiplying this whole function by 2 and then divided by 7, but the whole thing. So it doesn't just apply to x, it applies to x minus half. That's everything. So what ends up is 1 over 2y minus 1, and we're going to do some mathematical manipulation here. This is what we have, same thing. And we're going to flip it now. So then this 1 over 2y minus 1 becomes 2y minus 1. And this 7 actually goes to the top. And it becomes 2 times x minus a half. And we go 2y minus 1. Or in fact, actually, we can go 2y equals to 7 over 2x minus a half plus 1. And then we're going to expand this a bit, so we get 7 2x minus 1 plus 1. And then we divide everything by 2, and we get 7 2x minus 1 plus a half. And if you just look a bit, doesn't this look a bit familiar to you? So let's come back up. 7 over 2x minus 1 plus a half. If I look at my original equation, that is 7 over 2x minus 1 plus a half. So that's actually fx again. So what we have is the y here is actually now inverse because we're finding the inverse, right? The f inverse is equals to fx, which is equals to half plus 7 over 2x minus 1. And that, guys, is the magic of question 18. Everything comes back to something very simple. So your inverse is the same as your graph, and your composite, as we found earlier over here, was actually just x, with a special extra point here where you have to exclude it, so the domain can't be half. And guys, that is how you answer question 18. I know a lot of algebra in this one, but I hope you found it useful. Hope you liked the video. If you have any other questions, leave a comment below. Otherwise, like, subscribe, and I'll see you in the next video. Thanks for watching.